Hello! Today we're going to be talking about data types, and specifically, we're going to be giving one of the reasons why data types are required and necessary. Some languages do this for you, other languages you have to tell the computer which data type you are using. And remember, dynamic languages do it for you. A computer, it uses zeros and ones. That's all it knows. It uses those zeros and ones to calculate everything, and it must calculate the zeros and ones in different ways depending on what data type. So, without the data type, it just sits there confused. We're going to start off with a very simple one. We're going to start off integer. Integer is one of the most basic things you can represent with zeros and ones. Okay? We'll have two variables, x, and we'll also have y, and we're going to plug numbers into those, or, so you can visually see, we're going to drop the numbers into the buckets. Look at that. You see the actual binary values that represent 128 and 131. This is what the computer sees. The next step, let's add x and y together. The cool part is, now that the computer knows that these are integer values, it knows how to calculate those binary values, put them together, and come up with a new binary value that represents x plus y, 128 plus 131. So, let's add x plus y. We're going to talk to one of the processors, or actually the computer's going to talk to one of its processors. It's going to say, hey, we have two integers, add these together. In return, it's going to get a 259, and boom, now the computer has the correct value. But remember, zeros and ones. We see 259, they see zeros and ones. They as in the computer. Now let's get rid of this integer and let's replace it with a char. A char is just a data type that represents like a letter, a symbol. It's something you would see on your keyboard. All right, with the char data type, we have one extra step. When you press a key on your keyboard, you are producing an integer value. Remember, computers only know zeros and ones, which means these key combinations are actually represented by numbers, not the letters and symbols we see. In this case, the euro symbol was produced from 128, and 131 will also have its unique symbol that it represents. That's how it works. Your computer doesn't see these symbols, they see zeros and ones. That's why it's important to know the data type. I would like to clarify one thing though. It's the extended ASCII that we are using right now. So 0 to 127 is the same on most computers, but for me, in this case, 128 is a euro symbol and 131 is a function symbol. That might not be the case for every computer. So what happens when we add x and y together when they are char values? You will get an outcome of the euro symbol and the function symbol just being shoved together. This is what we call a string. And as you can see, the reason we knew to do this is because the data type was char. X plus y, same binary values, different outcome. And the entire time, we've had 128 and 131. Let's change that. Now we're going to do a signed integer. This means that these values will actually calculate a different decimal number. This time, negative 128 and negative 125. Our computer used the same ones and zeros to calculate a different decimal value. And without this ability, our computer wouldn't be able to calculate anything with a negative number. So this is a good thing. Data types are important. If we add x and y together, we will get a negative 253. As you can see, it's just a giant combination of 1 and zeros, but for us, we see negative 253. Different outcome, same binary values. All right, let's take a step back and actually look at our previous examples. In integer, we got 259, the same ones and zeros for x and y. For this char, we got a euro symbol and a function symbol. For this signed integer, we got a negative 253. Same ones and zeros for x and y, different calculations. All right, I know that was kind of a lot. Don't worry, we're done for now. Next time, it's going to be another video on why data types are necessary. Bye.